السلام عليكم ورحمة الله وبركاته. My name is Anas Walid Al-Maghrabi, and this is the first group project. We will represent that we are a hospital and we will choose the imported equipment after defining the specification that we will choose for the hospital. This is my team that will help me to choose the files for the hospital, consisting in Walid Batawil, Abdullah Kinani, Ahmed Muslimani, Abdulaziz Al-Saadi, and me. In our agenda today, first we will talk about ultrasound imaging with me. Then we go to magnetic resonance imaging with Walid Batawi. Then X-ray imaging with Ahmed Muslimani. After that, computer tomography with Abdullah Knani. Finally, we talk about gamma camera with Abdulaziz Al-Sadi. So what is ultrasound imaging? Ultrasound imaging uses sound wave to produce pictures of the inside of the body. So now we talk about specification and features required for ultrasound device in our hospital. So first, cart basic, we need it one because it's easy to move it in a hospital. The second thing, clinical application, we need to use it in abdominal because most devices of this type are specialized in this area. Then Doppler modes, we need 3D Doppler, color Doppler, continuous wave Doppler, pulse wave, because we needed quality imaging. Then the weight, we needed 40 to 80 because easy to move it in a hospital. Then imaging mode, 2D, 3D is enough. So in our features, we needed general imaging, excellent imaging quality in every mode, more comfortable, not highway, and must be easy to move. The first candidate we have is control medical imaging performance. The specification of this device is first cart-based one. The clinic applications use it in anesthesia. Then Doppler mode use spectral Doppler and color Doppler cannot MM mode. And weight 64 kilogram. Then imaging mode 2D and 3D. In the features, it have excellent imaging quality in every mode and advanced ergonomic workflow and connectivity and ultrasound platform. The second candidate device is GE Healthcare Logic P5. In specification, it has a card-based one, clinical application, use it in abdominal and colorectal. Doppler mode, it has 3D color, continuous wave, pulse wave. The weight is 74 kilogram. The third candidate device is Philips HD5. In specification, it has card-based one, clinic application to use it in abdominal, imaging Doppler, pulse wave, tissue, imaging use 2D, 3D, and weight is 47 kilogram. The features of this device, first is have a range of imaging modes help user see what they need to see. The second, study manager for easier. Advances connectivity to help user manage user data. Now, after we finish 3D files, we must choose for the hospital. So we choose this device. It's GA Healthcare Logic P5 because it meets the specification we set, and the device has good extras. For example, imaging mode, we need 2D, 3D. It has imaging 2D, 3D, and 4D. Another example, a clinical application, we need it to abdominal. It has abdominal and colorectal. Now we finish ultrasound. Now we go to magnetic imaging with Walid Batawi.
Assalamu alaikum. My name is Walid. I will talk today about the magnetic resonance imaging. What is the magnetic resonance imaging? MRI is a medical imaging technique that used a magnetic field and computer-generated radio waves to create detailed images of the organs and tissue in your body. For specification required in our hospital, for the first one, gantry aperture, range between 500 to 800, magnetic weight tons, range between 4 to 4.5, magnetic field strength, range between 2.5 to 3, line of sight, range between 500 to 550, gradient slow rate, range between 180 to 200, type of magnetic, superconducting, wide MRI scanner, only yes, maximum patient weight, range between 200 to 230, max gradient amplitude, range between 13 to 45, zero room, oil of technology, only yes. We have a multiple choice for to choose what is the best one in our hospital to choose device. For the first one, Philips achieved 1.5 Tesla MRI. The specification for this device: magnetic field strength 1.5, gantry approach 600, gradient slow rate 122, magnet weight 2.9, max gradient amplitude 33, maximum patient weight 215. For this device we have some feature for this one. For the first one, Philips 1.5 Tesla achieved 16 channel MRI system. Third one, 16 RF channel. For the serial 8910. For the DOM 2003. Running revision 2.2.3.5 software. RF amplifier type S23 underscore 64, gradient amplifier type 271D, gradient interface type GCI2, magnet type F2000 acquisition system CDAS DAS cabinet DACC. For the last one, helium 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 level 61%. For the second device we select refurbished GE Optane MR360 1.5 Tesla MRI. Gantry aperture 600, maximum patient weight 160, magnetic field strength 1.5, type of magnetic superconducting, max gradient amplitude 33, line of sight 48, gradient slow rate 100, weight pool MRI scanner no. For this device we have some features. For the first one, 8, 60 or 32 channel to suit your needs. Sense imaging sense can be combined with virtual every scan method for clinical benefit such as reduced scan times, higher temporal resolution and enhanced spatial resolution. The system is available with pulsar gradient amplitude 33, slow rate 80, nova gradient 33 over 160, and nova dual gradient 33 over 160 or 66 over 18. With modular 32-channel architecture, FreeWave is designed to handle the large data streams of high-resolution imaging with matrix up to 2K x 2K, 4D track, K-T blast, and other acceleration method deliver fast scanning. With up to 32 RF receiver channel and extensive range of high channel receive coil and powerful sense 16 acceleration, it allows access to advanced applications such as 4D imaging and real-time imaging capabilities. For the third device we selected in our hospital, Philips Ingenia 3.0 Tesla MRI, gantry aperture 700, magnetic weight 4.6, magnetic field strength 3, line of sight 550, gradient slow rate 200, type of magnet superconducting, wide for MRI scanner yes, maximum patient weight 250, max gradient amplitude 45, zero helium foil of technology yes. The feature of this device: 1. 70 cm body provides more space and helps to reduce encased. Smart software to reduce retakes, increase consistency, and exam speeds. Digital coil design greatly reduces coil weight and leads to less patient representing in many exams. The ambient light brings on the magnet effect and adjustable in poor lighting enhance the openness of the system. Patient perceived gradient acoustic noise is reduced by more than 80%. At the heart at the heart of the Ingenium 3.0 Tesla is the new stream architecture. Direct digital RF receive technology, which dishes the MR signal directly in the RF coil at the patient. Flex-stream workflow, which increase system versatility and throughput through better coil and patient management. Easy expand, which enables plug-and-play expansion of clinical capabilities without major hardware upgrades. This device was selected based on the specification and the need of the hospital. Now we continue with my friend Ahmed Muslimani. Thank you.
Assalamu alaikum. My name is Ahmed Musulmani, and today I'm going to talk about the X-ray imaging and discuss the hospital's requirements of specifications to the devices we want to buy. First, the X-ray, as we know, are type of radiation that can pass through the body, and they can't be seen by the naked eyes, and we can't feel them as pass through the body. The energy from the X-ray is absorbed at different rates by different parts of the body. A detector on the other side of the body picks up this X-ray after they pass through the body and turn them to the into image. So the managers of the King Faisal Specialist Hospital has told us that the hospital wants to buy a new X-ray devices, and this is the specification requirements. It should be floor mounted and not portable. The frequency must be from 50 to 60 hertz, and the peak voltage should be uh, not less than 19 kilovolt peak, and the current 250 milliamperes. Operation moderation must be automatic, and it should be digital, and the application should be from nursing home and hospital. The power source, it's electric, and it must have the feature of connected to internet, and the year of manufacturing should be after 2040, and the cost should not be more than $50,000. So after a lot of searching and asking local medical company that buys medical devices, we found the three model of X-ray that we want to buy, but we have to decide which one is match our requirements. First one, it's named Philips Digital Diagnostic 15. It's floor mounted, not portable, same frequency we want, but the peak voltage is 200 kilovolt, and the current 620 milliampere. Its operation is automatic and digital, but the connected to internet is unavailable, which is a huge object. We cannot We cannot ignore this because the hospital specification wants it to be connected to internet, and the cost was $75,000, much more than the hospital expecting the cost. The second device was the Elerio Mastro 4010 MA HF DC X-ray machine. It's floor-mounted, non-portable, same frequency we want. The peak voltage was 100 kilovolt peak, and the current was 350 milliampere. It was automatical, digital, electrical. Even the connected to internet were available. The year of manufacturing were 2060, and the cost was affordable. The third device was Medion Healthcare MXHF. It was as the same each to before, floor mounted and not portable, same frequency, but here the peak kilovoltage was less than what we want. It was 70 kilovolt, and the current was also less than what we want, and the year of manufacturing was 2012. So after we analyzed all these specification of three models of these three devices, we found that the second one is the best choice. Even the peak kilovoltage and the current of the second devices was a little bit higher than what we want, but we can control and adjust this value. And thank you for your listening.
Assalamu alaikum, my name is Abdullah, and we're going to continue with the computed tomography, CT. Computed tomography is a scanning device. What is the benefit of the CT scan and why is it important? Well, the CT scan, it can, scan the, let's say, the surface of the thing that you want to scan. It's like kind of the MRI, but it's more simple and more specific about, some sort of a point, like the brain, if you want to see if there's a tumor or there is some sort of bleeding inside the body in some specific place. There's types of the CT scan. There's the micro, the industrial, the meteorology, and the horizontal and the X-ray planar. Well, in King Abdullah Hospital, they asked for a device that it's not. They didn't ask for a big specifications, but they asked for a good device. So we're gonna see the devices now. The first device is a microtype. The device name is Nano Voxel 2000. The device feature and advantages is that the device is tube sealed X-ray source. No need for consumable and simple maintenance. It have a large chamber with a good expandability. It have a high spatial resolution of 0.5 micrometer. Multiple scanning modes, which is the spiral, offset, and limited angle, and others. We're gonna see the specification down here. For the specification of the device, in this slide we're gonna see the resolution, X-ray source, director, and in the other slide we're gonna see the sample and the equipment. The resolution, the stability is 1 micromilli. Flat panel director, 50 nanometer objective coupling director, and this spatial resolution is 3 micrometer. Flat panel director, 50 nanometer objective coupling director. The voltage is 150,000. It's the X-ray sources, as we said, is sealed and reflection. The imaging area, which is the director flat panel, is 244 millimeter by 19.5 millimeter. Pixel matrix is 1920 by 1536. The weight, the maximum size is 400 millimeter by 300 millimeter. Diameter by height. Maximum weight is 15 kilogram. The equipment is that the dimension is 1620 millimeter by 1100 millimeter by 1700 millimeter, which is the length, width, and the height. The weight of the equipment is 24 kilogram. The next device is industrial CT type. The device name is multi-scale voxel 1000. The feature and the advantage of the device is high voltage X-ray sources with strong penetrating ability to high density metal. It's having a flat panel director and linear array director to meet the diversity testing needs. It's have a spiral scanning and offset scanning to further expand imaging area, and it have a simple scanning process, rapid reconstruction of imaging, and programmable scanning process to ensure the consistency and convince of patch sample testing. Detected algorithm to enhance imaging clarity and obtains high quality imaging quality. Okay, continuing with the specification. We have here the resolution, X-ray sources, and director. The resolution, this data stability is 30 micrometer. The X-ray sources, the tube type is sealed. The voltage is 600,000 volts. It's also, as we can see, it can be for 500,000 volts or 450 volts. It's something in the range like this. The minimum is 450, the maximum is 600. The focal spot size is also can be 0.7 millimeter at 0.7 kilowatt or 0.4 millimeter at 0.7 kilowatt, or it can be 2 millimeter at 1.5 kilowatt or 1.0 millimeter at 1.5 kilowatt. The imaging area is 427 millimeter by 427 millimeter. The pixel matrix is 3072 by 3072. The sample and equipment of the size is going to be in the next slide. The sample and equipment. The sample maximum size is 900 millimeter by 1100 millimeter, which is diameter and height. Maximum weight is 100 kilogram. Dimension for the equipment is 7300 millimeter, 2300 millimeter, 2900 millimeter, which is the length, width, height. The weight can be from 35,000 to 60,000. The third and the last device is also a micro type. The device name is NanoVoxel 5000. The feature and the advantage of the device is one button to switch from X-ray source, excellent testing performance, and flexible setting. Multiple scanning modes such as spiral, offset, limited angle, and others. Excellent expandability. The specification of the device, as we saw before for the other tools, we have here the resolution, X-ray source, and the director, and we're going to see in the other slide the sample and equipment. The resolution, the disability is 200 nanometer. Spatial resolution is 500 nanometer. The X-ray tube type, we have the open reflection and we have the open transmission micro nano focus. It's not like the other two, which is sealed. No, this one is open. The voltage is 300 volt, 240,000 volt, 225,000 volt, 190,000 volt, 160,000 volt. That's for the open reflection. For the open transmission, we have 240, 225, 1900, 1600. For the detector first, a flat panel, the imaging area is 427 by 427 millimeter, of course. The pixel matrix is 30, 75, 72, 30, 72. It's like the the device before that, which is the multi-scale voxel 1000. For the sample and the equipment, the maximum size is 600 millimeter by 600 millimeter diameter and height. Maximum weight is 25 kilogram. Dimension is 2770 millimeter, 1540 millimeter, 2040 millimeter. This is length, width, and height. The weight is 80,000 kilogram. This device, the voxel, nanovoxel 5000, is the ideal device for the hospital because it's not that, let's say it's not that a great device that's gonna cost us a lot, and it's not that poor device which is that is not gonna help us a lot. It's in a mid-range device. It have all the feature that we need. It have all the things that can help in the hospital. The weight, the size, the imaging, the area, it's all perfect for the hospital. So we decided to choose the nanovoxel 5000 for the King Abdullah hospital.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Abdulaziz Saadi. I will talk about the gamma camera and the specification and future requirement for the hospital. Gamma camera is an imaging device used to image gamma radiation emitting radioisotopes. This technique is known as scintigraphy and is used to image and analyze the distribution of gamma emitting radionuclide medically introduced into the human body. Specification and future requirement for gamma camera. In this schedule we talk about the specification, gamma type camera, weight, height, width, patient weight, capacity. Gamma camera type spec CT, weight 97 60 pound, height 88.58 inch, width will be 90.94 inch. Patient weight capacity will be 500 pound. Future automatic body contour for SPECT and whole body imaging, automate simultaneous deal metal change, rectangular at least 500 millimeter, 385 millimeter FOV. Siemens gamma camera. In this schedule, I will talk about the specification. First, I will talk about the application in hospital. Brand Siemens. Crystal thickness will be 9.5 millimeter or 15.9 millimeter. Detector geometry. Others. Detector material. Sodium. Gamma camera type specs T. Generate configuration order. Patient weight capacity 500 pound. Power requirement 380 to 480. Spec model 1 stand. Weight will be 97 60 pound. High will be 88.58 inch. Width will be 90.94 inch. Future automatic body contours for SPECT and whole body imaging, flash 3D and generative reconstruction, rectangular 533 mm, 387 mm OV. GE Healthcare Minimum VG Gamma camera. This specification for this device: dictator, camera 10, deal head, variable angle, gamma camera type SPECT CT, high 83 inch, length 69 inch, patient weight 540 pound, weight 5600 pound, width 83 inch, application in hospital, minimum hour quantity 1 set. Future slip ring gentry along unlimited tomographic precision, external mounting detector, automated body countering, automated simultaneous deal commutator changing, rectangular 500 mm 400 mm FOV. Their device Philips skylight, crystal thickness will be 0.375 inch, detector diameter, deal head variable angle, detector material sodium lead, gamma camera type, SPECT, gentry configuration, open. Future first concurrent simultaneous acquisition, overlapping energy window, integrates commutator exchange, patient load from either side the table, rectangular 508 mm 381 mm. I hope that you have benefit from the device we talked about in terms of specification and future. Thank you for listening.